All right, let's get started. So a rotation. Um, Yesterday we talked about reflections, and a reflection was something where you needed a line of reflection so you could figure out how far the figure was from that line and then reflect it over the same distance the other side. With rotations, we don't use lines anymore. We use a point. Okay, think about like a spinner on a board game. Okay, when you spin it, there's always a center of rotation in the middle of that spinner, right? Might be like a little brad or something down through the middle of it that holds it in place while it goes around that. Okay, so what we're going to do then is we're going to identify some kind of a figure we want to rotate, and then identify where the point of rotation is, and then use that to take that figure and, based on a certain number of degrees we want to rotate it, move that and then plot it where it needs to go in its new location. Okay, so here's how we do it. So rotation, so using a point of rotation, we will turn an object a certain number of degrees and we can do clockwise rotations and counterclockwise. Okay, so that's pretty much it. And like the other sections, we're going to stick with the coordinate plane. And to further simplify things for you guys, the center of rotation will always be 0, 0, the origin. Okay? So, and we're going to look at just rotations of like 90 degrees, 180 degrees, ones that aren't crazy so that you can more easily see where the thing has been rotated to. Okay? So, we're going to first start by doing a rotation manually, which means you're going to use your protractors to do all the measuring of the angles and everything. But you're going to find there's a shortcut. After we've done the first one, we can kind of take a look at what the shortcut would be. And then from there on out, we can just use that shortcut to help us get through it. Okay? So give yourself a good amount of room here so you can use your protractor to do it. So I'm going to use up like the whole page here.
Whole page?
Well, not that big, I guess, but pretty big, though.
How many?
At least 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, probably 10 in every direction would be good. You guys enough room where your protractor will fit on the page so you can actually use it effectively. So I think that's probably good enough. Yeah, my x-axis is a little long here, but it's all good. So yeah, I'm taking up a good portion of the page here. All right, I'll back that up just a little bit so you can see it better. All right, and so we'll start with, we'll do a triangle. Take this triangle here. Alright, just color ABC there. Say what? Negative 7, 8. Yeah. All right, and so what we're going to do with this one, we are going to attempt to rotate this triangle 90 degrees clockwise. Okay? So we're going to need to use some little construction lines, kind of like we did with the reflections. We're going to take each one of these points, and we're not going to move them. We're not going to like count how far away they are from a line. That's doing the reflection thing. But we're going to connect them all to the point of rotation. So that point of rotation, like I said, is the origin for all of these. Okay. So let's do some dotted lines. So each one of those points do a dotted line to the origin. And you can use your the straight edge part of your protractor, because the more nice and straight we can make these, the better it's going to be when we're done. Okay, so it looks something kind of like that. Now what I'm going to do, just so it's easier for you to see, I'm going to use some of my gel pens, put some color on this thing. Because sometimes you can get kind of lost in what line is where and that kind of a thing. So I'm hoping this will help clarify some of that. But you guys just stick with your dotted lines and that's fine. But I'm going to go over mine with some color. All right, now this line right here. Okay. If I can take that line segment and rotate it 90 degrees, the end of that line segment should be where the new point B should be. Does that make sense? Just take that line segment, rotate it, and wherever the end of it ends up, because the one point is going to stay here, and the other end, the point B, is going to swing around 90 degrees, and wherever that thing ends up, that's going to be the new coordinates for B. Okay? So using a protractor, we need to figure out where that 90 degree mark would be. Okay, so I'm going to take my protractor, line up at the origin, the bottom of it, make sure I'm flush with that line, and then 90 degrees is going to be up here. Okay, so put a little dot above the 90 degrees here, and then I'm going to make a line from the origin, just another little dotted line to help me here. Okay, so again, this is just from this green segment, this is 90 degrees. Now, what's the other thing that I need to figure out yet? I've got the angle correct, but don't I want to make sure that this point still stays the same length out? That segment should still be the same length it was when I started, right? So I got to make sure that I can measure their length. Oh, and you guys can't do that without rulers. Okay. Emergency ruler pass out. Who can help me really fast? Okay. Oh, you haven't done anything yet. Here you go. Okay, any event. So I'll show you with mine, but yeah, we need rulers. Sorry. We won't after this example because, like I said, there's a shortcut. You can go to a table and we should be fine. So, length of it here, I'm doing centimeters. Looks like I got somewhere in the neighborhood of 3.7. Okay. So I'm going to go out 3.7 centimeters on here, and that should be about where that segment would have ended up after I rotated at the end of it. So 3.7 puts me about right here. All right, so I did centimeters. Yeah, I measured it to be about 3.7 centimeters. So I measured 3.7 centimeters out on the new line there. And so that's going to put my B prime about here. Okay, so I've rotated that point, and now I got to just repeat that process for the point A and the point C. Okay, So I'll go to point A next. I'll make this one pink, I guess. All right, if you didn't catch exactly what I did there, just pay attention to this one, and then you can just repeat it for the last one. So I'm going to use this pink line now. I want to make a 90-degree angle again. So I'm going to take my protractor, put it on there, make sure the bottom of it is at the origin, swing this thing up. So that's right over that pink line. And then find my 90 degrees right here. Okay. So now I'm going to get a new dotted line coming up this way for that one. But again, I want to make sure that the length of that segment, the original pink segment I started with, it has to be the same length when I rotate it so that that point A is still the same distance away from the origin. So I'm going to go centimeters again here. Let's see what we got. Looks like I'm sitting at about 6.9, close to 7, almost 7. So if I come out on this new dotted line here, when I go almost 7, that's going to put me about right here. All right, so that's going to be my A prime. Bless you. Okay, shh, quiet please. Okay, so that's that segment rotated, and then I got to do the last one yet. Same process. So I'm going to go make this one blue. Question?
How did you get that full length of that, like on B? How did you get that full thing in pink, and then on B prime, you only got it halfway?
B prime goes with this one.
Oh, so you just measure how long that segment is there.
Right, I measured how long this was and then went the same distance out that way.
Right.
This one I measured how long this was and then went the same distance out that way. Yep. And I'm going to do that same thing here with C. Rotation first. So I'm going up the blue line this time. Alright, and then I find 90 degrees here. So I can connect that to the origin. That's my construction line for C. Alright, let's see how long that blue line is there. So that's in centimeters looking like about, I don't know, 4.6, 4.7, somewhere in there. So if I go about 4.6 or 7, I'm ending up about right here. So there's my C prime. So make that one blue. Okay, so I'm going to move this B prime to the other side here because it's going to get in the way of my triangle. But if I put these together now, I should have my triangle all rotated. Okay? Okay, so see if you can kind of visualize in your head this triangle making its journey here. Okay, it's rotating, okay? So like pretend like all of these lines are static. The green, the pink, and the blue are all static, and they're all like connecting this thing together and swinging it around this point. So this triangle kind of does one of those. Okay? It's almost like a kite. Yeah, it just kind of was in the breeze, just over 90 degrees. Anyway, so now let's take a look at the coordinates here with A and A prime, B and B prime, C and C prime. See if we notice anything there. Because like I said, there's kind of a little trick to this. So A started at, what was it, negative 7, 8. B started at the point negative 5, 3. And C started at the point negative 2, 7. All right, so take a minute. I would like to locate the ordered pairs for A prime, B prime, and C prime. Write those down. And then see if you can figure out what the pattern is. Okay, so take a minute and do that on your own. Write down the new coordinates of those 3 points and see if you can determine what is going on here. All right. So, Stephen, what's A prime? What are its coordinates? 8, 7. Awesome. Seth, B prime. 3, 5. And, okay, Tiara. 7, 2 for C prime. Raising their hand. What's going on here, Jason? Okay, so we've got, it's kind of like that reflection over y equals x where the two switch, right? But it's more than that, right? They switch, and what else happens? The x changes, yeah, it loses its sign, essentially, or switches its sign as well. So, as a rule, what would that be then? xy goes to what? Changes to what? There it is. Y negative x. The y moves to the x position, but it doesn't change its sign, right? It's the x that changes its sign, right? And it becomes the y. So, yeah. xy goes to y negative x. Anytime I ask you to rotate a picture 90 degrees clockwise, you can use that. It will work for every point, no matter what. Okay. There are some other rules. I could sit here and have you guys try the 180 degree one, try the 270 degree one, and do all that. I'm just going to tell you what the other ones are. It works the same way, okay? So, yeah, 360, that's a real tough one. Anyway, so these are our rotation rules for coordinates. And remember before with all of the reflections and translations, I said, if you can remember the rules, great. If not, just draw it out and try it, and it always works. It just takes a little longer. This one, I really want you to just memorize these rules because, yeah, you know what I meant. Anyway, because doing this by hand is not terribly fun, right? It takes a bit of time. Maybe you think it's fun. I think it's fun, but it just takes a long time, though. So if you just remember what these rotation rules are, you're going to save yourself a lot of time. All clockwise, by the way. If I ask you to go counterclockwise, all you got to do is match it with the one that would be the same thing clockwise, and it works. We'll talk about that later. Yeah. So 90 degrees, that's the one we just found. Okay, xy goes to y negative x. 180 degrees. This one is negative x, negative y. That one's kind of an easy one to remember. They just both switch their signs.
360.
270 is going to be y. Yeah. So that would be negative yx. Yeah.
That makes sense.
Yeah. I can do the 360 if you want. That was 270. Now, what should 360 be?
Whoa.
XY. Just right. It's right back where it started.
I thought it was
Maybe I'll throw one of those on the test just to keep you honest. Make it a nice, easy one for you. Okay. So now like I said, if you know the clockwise rotation rules, you really know the counterclockwise rotation rules too. If I ask you to rotate something 90 degrees counterclockwise, I say that again, 90 degrees counterclockwise, which one of these are you going to? Yes. 270, right? That makes sense? If you go 270 one direction, it's the same thing as going 90 the other, right? So that's really the same thing. What if I asked you to go 180 degrees counterclockwise? Careful. It's still 180. Don't you end up in the same place if you rotate 180 either way? What if I ask you to go 270 counterclockwise? Same thing as 90. What if I ask you to go 360 counterclockwise? Still the same thing as 360, right? So you can do any of those using these rules still. You just got to think in your head, kind of visualize which way. Okay, so the 270s and the 90s just kind of swap. 180 is 180, 360 is 360. It's not too hard. Okay, so let's try to give you guys some coordinates, give you a rotation. Can you tell me what they should be? Okay? All right. All right, so we're going to do triangle bad. 90 degrees counterclockwise. B is going to be at 3, negative 1. A is going to be at negative 2, 7. And D is 0, 4. Okay, so 90 degrees counterclockwise. You need, apply the rule, give me those 3 points. All right. Oh, one moment. Coordinates for B prime, Nolan. It would be, let's see, so we're going 9 degrees counterclockwise, so that's the 270. So it would be 1, 3. Yep. Right, so we take the y, swaps with x, that becomes and then the x becomes y. Okay, so we're going to keep following that same kind of pattern. So, Devin, can you give us a second one? -7, -2. Good. All right, somebody else who has not answered anything yet today. There he is. -4, 0. Yep. Okay. So I think you guys can probably handle this. And in your homework, they might have you graph it too, and you guys can all graph points. So I'm not going to really spend time doing that. So can you do a rotation and then a reflection, or a rotation and then a translation, or something like that? So let's give that a try. We'll do a little segment here, and then we'll graph this one too. Yep. So we're going to rotate. We'll do the segment CE, 100 degrees clockwise. And then reflect it over the y-axis. Okay, and here are your coordinates. So C is going to be the point 2,5, and E is going to be the point, let's go 5,8. You might not have to. We will, just so people can see it, but I'll explain how you can do it without graphing it as we go too. All right, so down here, we've got a little bit of room. I think use every box equal to 2 for this one, just so we can see it better. Otherwise, it's going to kind of go off the page. Okay, so this little segment is at 2, 5. There's C. And then E is at 5, 8. So there it is. There's the segment. We're going to rotate and then reflect. All right, so I want to go 180 degrees and then reflect it. So let's just do it one thing at a time. Don't worry about the reflection. Just do the rotation first. Follow the rule, okay? 180 degrees clockwise. We've got that over here. X, negative y. Okay. So after the rotation, now we have C prime is at -2, -5, and E prime is at -5, -8. Rule, right? Okay, just make everything negative. Okay, well, let's plot that out then real quick, okay? Let's see what this thing looks like after we do that 180-degree turn. So -2, -5 is right here. There's your C prime. And then E is -5, -8. So right here. Okay, so that's been rotated 180 degrees. And now I want to take that and reflect it over the y-axis. Well, seeing that now, the reflection's easy. Just like we did yesterday, you just count over to the y-axis, count to the other side of it, and there you go. Okay, so this is 1 unit to the y-axis, or 2 units rather to the y-axis, so 2 units on the other side of it. There's your C double prime, I guess now, technically, right? Then we've got 5 over from E, so 1, 2, 3, 4, 5 for E double prime. There it is. Okay, and then it's just a matter of recording down what are the coordinates of those new points we just got after we did that reflection. Okay, so what are the coordinates of C double prime? Where's it at? Yeah. 2, -5, right? And what are the coordinates, somebody else, of E double prime? Yeah, Savannah. -8, yep. So this would be your final answer after that reflection. Those are the coordinates that we had. Now, I don't know if anybody noticed this. Yes? Nope, it's not that. Yeah, this one's just reflected over the x-axis. Now, that doesn't mean every composition is going to do that. This one just happened to work out that way. But usually, a composition you can describe in just one movement. So you can take this rotation and reflection and say, oh, that's really just one reflection. If you want to get from here to here, what really happened? Just one thing reflected over the x-axis. Okay? You're not always going to be able to see that, so it's easier just to do it and then figure out where you're at. Yeah?
I don't know if it says graph that, and we just can do it using not using the graph. Do you have to graph it?
If it says graph it, you still have to graph it. Yeah, there's still some value in doing that, even if you can do it in your head at this point. Okay, so are we okay with the compositions? I only did one example, but it's really just do the one thing first and then do the other thing second. And if you draw it, it makes it easier. Okay? So I'm not going to do a ton of those. I just wanted to do the one example to show you how that works. But I think you guys, if you can do rotations, if you can do... Guys, quiet please. If you can do a rotation, if you can do a reflection, if you can do a translation, which I think all of us can at this point, then it's just a matter of following the things in order that you're supposed to do. And then a composition is no more difficult than anything else you've done. Question, Zach?
I don't know what we get to use our
Protractor? No. Because now that you know these rules, those are the only kind of rotations I'm going to have you doing. So the protractors, well, that was just to kind of figure out what's going on, and from here on out, just follow the rules and you're fine. One is rotational symmetry. We talked about lines of symmetry yesterday. There is a thing called rotation symmetry as well. Not exactly. Sorry. We're going to go back to our square here. Thank you. So if I rotate this square to look for rotation symmetry, what I really want to do is I want to pick somewhere in the picture where I can put that point of rotation so that if I rotate the square, it rotates right onto itself. So where would be a good place to put that point of rotation? Yes, sir. Right smack dab in the middle. So that's the thing that you guys need to figure out when you're looking for rotation symmetry is, can I put a point of rotation somewhere that will let me rotate this thing and have it rotate onto itself? And usually it's going to be right in the middle of whatever you're looking at. Okay? So then the question becomes, okay, yes, so the square does have rotation symmetry, but how many times can I rotate it and have it click right back into shape? Yeah, 4. Okay, now if you have a hard time doing that, I'm going to draw this square 3 more times, rotated. And maybe you have this, and if you do, that's fine, because not all of us can see rotations in our head easily. I know when I was a student, I struggled with this at first. Okay, so let's just assume we're going clockwise rotations again. So if I rotate it, just kind of click, this B is going to travel down to where C is. C is going to go over to where D is. D is going to come up to where A was, and the A is going to be over where the B was, like that. Okay? So that would be where this is our point of rotation. Okay, do you guys all see that? I just did one click, it gets me to there. If I rotate it again, I'm going to have A, B, C, D. And if I rotate it one more time, it's going to be B, C, D, A. And then one more click and it's right back to where it started. Okay? So there are, with that point of rotation in the middle, there are 4 different orientations this thing could have. Okay? So yes, it has rotation symmetry, and there are 4 different ways we can do that. Okay? So 4 rotations gets the job done for this one. Okay, so let's take a look at a few other figures here. I might have to E, F, and G. So does the triangle EFG have rotation symmetry? And if so, how many ways can I rotate it and have it click right back to where it is? Yeah. There's none. That's right. Or I guess you could say 360, right? If you rotate it 360, if you put that rotation somewhere in the middle there and flipped it all the way around, sure. But any object can do that, right? Any object you can rotate 360 and put it right back where it started. So this one, technically, you would say has no rotation symmetry then. We can't rotate it and put it right back where it started. Okay, how about... Now this one, you have to assume that this is a regular polygon. So I'm not entirely certain that this is, but... Okay, so like it's like a stop sign or whatever. So does this one appear as though it has rotation symmetry in it? Okay. And we'll put some letters on here. H, I, J, K, L.
Wait, is that the way you do it? I thought you could like... Alright, never mind.
And for this one, would be again smack dab in the middle there. So, without actually redrawing the thing like we did the square, how many different rotations do you think I could get on this one? Assuming it's a regular polygon. Every edge is exactly the same length. All the angles are exactly the same. How many clicks do we get? Yeah, there's 8. Yeah. Now take a look. The square had 4. The octagon had 8.
No way.
Notice a little pattern there? If it's a regular polygon like that, and that's only for regular polygons, but if it's a regular polygon, it is the number of sides is how many times you can turn it. So this one, yes, it has it, but it has 8 rotations you can do. Yes?
So is it pretty much if all sides are the same length, then it has rotation?
If it looks like a polygon like that, then yeah. There's some in your homework that are going to be a little bit different. It just kind of depends, but I think based on kind of here, I think you guys can kind of riddle your way through it a little bit. Question, stretching. What? That's a good question. No. Yeah, so the rectangle is only going to have 2. Mm-hmm. You can do it 180 degrees and then right back to where it started. Yeah. Okay, I'm going to stop there and let you guys start on your homework. You got about 15 minutes.